Okay, in this video, we're going to be going over RL response circuits and how to solve the following circuit. So, first we're going to find or calculate the initial value of I, which is I going across this inductor. So, in order to do that, we are first going to place the switch in the closed position because we want to find the initial. So we're going to draw it with a closed switch, and then we want to get the current going across this inductor. And remember, since the switch has been closed for a long time, the inductor will turn into a wire. So now that this is a wire, we have to remember that current is going to take the path of least resistance. So we can pretty much get rid of this 2 ohm resistor right here because none of the current is going to go through it. So we can just get rid of that. And now we can begin solving for the current right here. Now, first thing that I would do is I would turn this into I would use a Norton transformation to turn this voltage source into a current source. So we'll take our calculator and do 160 divided by 3 to get 53.34 rounding. So we'll redraw the circuit over here with the current going up and our resistor in parallel with it, our 3 ohm resistor. So this will be 53.34 amps, and our 30 ohm right here, our 6 right here, and we need to get the current going right here. So now we can start making some combinations, especially these ones that are in parallel right here. So if we do the inverse of 3 plus the inverse of 30, and then the inverse of our answer, we'll get a resistance of 2.72 or 2.73 when rounding. So we'll redraw our circuit again with a resistor value of 2.73 and another resistor right here of 6, keeping our 53.34 amp current. Now, in order to get this current that's right here, we can use a current divider. And remember, our current divider equation is as is. We have current out is equal to R2 over R1 plus R2 times our current in. So, replacing our variables, we'll get 6 over 20 or 2.773 plus 6 is equal or multiplied by 53.34. We'll plug that into our calculator. 6 divided by 2.73 plus 6 times 53.34, and we get 36.66 amps. So this gives us the current that is going through this resistor right here. So in order to get the current that's going through right here, we need to do 53.34 minus 36.66, which will give us a current of 16.68. This is because we the current from the current source is going in this way, and the current that we calculated using our divider is going out. And remember, the Kirchhoff's current law is current in equals current out. And that's where we got this equation right here. So our current at our inductor right here at 0 is equal to 16.68. Okay, now we are going to calculate the initial energy stored in the inductor. And to do this, we're going to use the energy formula. The energy formula is 1/2 for an inductor. Energy formula for an inductor is 1/2 I or Li squared. And we are just going to simply plug in our values. So E is going to be equal to 1/2 the value of our inductor, which is 8 millihenries, 0.008, times the current that we got of 16.68 squared, and we will just plug that into our calculator. 0.68 squared, and that's going to be equal to 1.11 joules. Okay, now we are going to find tau. The formula for tau for an inductor is going to be tau equals L divided by R. So, and this R is the equivalent resistance that the inductor sees when t is greater than 0. So if we look at our original circuit, we see that when t is greater than 0, the switch is open. So we can redraw our circuit, or I'm going to copy the circuit, bring it back down here, and we'll see that when t is greater than 0, the circuit's open. So if we look here, we see that the inductor only sees this 2 ohm resistor. So to find tau, we'll simply just plug in our values of 0.008 divided by 2 from our 2 ohm. We'll plug that into our calculator to get a time of 0.004 seconds, or 4 milliseconds. So now that we have tau, we are able to create the expression for the current after the switch opens, the current at the inductor after the switch opens. Because what the current's going to want to do, or what the inductor is going to want to do, is keep the same current after the switch opens. So, and let's remember the form for the discharge of the inductor is going to be x of t, or in this case it's going to be I. So I, initial I of t, e minus or negative t over tau. So we can replace these variables with what we found. So our initial I was 16.68, going this way in this direction down, but our circuit wants us to find the current going up. So that means that our current is going to be negative. Our initial current will be negative. Negative 16 point, what did we find? 0.68 2.68 e negative t over tau, which was 0.004. Or you'll also see it written with our tau at the top, and we do that by just finding the inverse of 0.004, which is 250. So we'll also write it as negative 16.68 e negative 250 t. And that is our current that is going through the inductor after the switch opens.